the Animal Health Center, will now be talking more in depth about those cases. Anne.
Can I use this microphone?
Yeah,
Because I'm
please.
gonna, yeah.
So, this is your...
Hello. Brian sort of misled you. I'm not actually going to be talking very much about the horses in BC, although I will focus on them. When I was asked to give this talk, I thought, well, what's my angle going to be? What am I going to talk about? Couldn't decide, so basically thought I'd talk about everything. So it's going to be quick, and it's going to cover a lot of territory, so here we go. So West Nile virus, what is it? It's a vector-borne Flavivirus infection, which utilizes an avian mosquito amplification cycle. And here's a little diagram that I got from CDC that's very nicely showing the cyclical activity between the vector mosquitoes and the avian host reservoir birds. They build up the virus load, and then it spills over into the dead-end hosts, humans and horses, usually late in the season in temperate zones like we have here in British Columbia. So it's the most widespread vector-borne disease in the world. The first case was reported in 1937 in Uganda, and that was in a woman, but the first horse was reported in Egypt in 1959, and from there it spread to South Europe and Northern Africa through the 60s. Basically, this is information about the infection in horses in North America. Most horses seroconvert upon infection without any serious disease. About a third of them will develop malaise-like syndrome. However, 8% of the horses will develop neurological disease. Ataxia is the most common sign, and during the outbreak in America, about 22 to 44% of these horses either died or required euthanasia. Up to 20% of the survivors of neurological disease will have persistent signs. And just to compare with the disease in humans, about 1% of humans are reported to develop neurological disease, compared with 8% in horses. So it's quite a devastating disease for horses. The first cases, of course, were reported in New York City in September of 1999, when a Flavivirus encephalitis was diagnosed in crows in New York City. They were falling dead from the sky, literally. It was also diagnosed in flamingos and pheasants in the Bronx Zoo. And of course, from there it spread across Canada and the US, mediated by the vector species, Culex species mosquitoes predominantly, and passerine bird amplifiers. It spread via numerous methods, probably migratory pathways, east-west spread, and probably with some assistance from us humans. There were barriers to the spread, and it resulted in significant regional declines of corvids, mainly crows and magpies, but infection of thousands of humans and horses. So it spread to Canada in 2001, 2002 in eastern Canada, Ontario, Quebec. 2002, 2003 hit the prairies. In that year, 2000, 2003, more than 15,000 horses were diagnosed in the US with West Nile virus disease, and almost 100% of the diseases that were non-human reported in that time were horses. In that time period, an efficacious equine vaccination was introduced, which helped to decrease the rapidity of the increase in cases that were seen, but unfortunately it didn't do away with the equine cases. So here I've thrown up a map just showing the spread of West Nile virus across America. Blue denotes non-human detections, and red denotes human detections. And this is 1999, and you can see here it is in New York City. 2000, it's spreading up to the Great Lakes, a bit down the coast. Over here, it's patchy across all of eastern US, quite a lot of activity in Florida where it's warm. And then in 2002, it just exploded across the US up into the prairie provinces here in Canada. And I want you to take note, it's hard to see because it's all blue, but there is some activity here in 2002 in Washington State. And from a sort of a continent-wide focus, and now I want to come and focus to Washington State and British Columbia. So here's some maps I took from Washington State, West Nile virus surveillance site, depicting West Nile virus activity in any species, including mosquitoes, birds, horses, and humans. And you can see 6 counties reported West Nile virus activity in 2002, nothing in the succeeding 2 years, and then again in Yakima County in southern state in 2005. And then all of a sudden it really took off in Washington State over the next 4 years, spreading beyond Yakima County to surrounding counties. And here in 2009, a lot of the southern states affected, but also up here in Whatcom County, they were detecting the virus, which of course is just a couple of miles south of us here in Langley. So 2009 was the year that we first reported cases here in British Columbia. And I've drawn up this table. These are West Nile virus horses, positive, who contracted the disease, we believe, in British Columbia. None of them had a travel history. So these horses were infected here in British Columbia. They were picked up mainly in August and September. And so I've laid it out here in this table the whole years. We had a total of 17 horses affected in province from 2009 to 2017. 3 in 2009, 1 in the Fraser Valley across from Whatcom County, and then 2 in the Okanagan. Skipped a year, 1 in the Okanagan, skipped a year, 1 in the Okanagan, skipped 2 years. And then last year and this year we had this outbreak in East and West Kootenays, where we had 8 horses last year and 4 horses this year. So you saw the pattern of infection. It jumps around from year to year. It affects this county one year, another county the next year. So I found that really interesting when I was preparing for the talk. So I thought I'd throw up this lovely map that you've seen before, which illustrates the pockets of West Nile virus activity cumulatively since 2009, of course, the first case in Langley, and the concentration of the human cases and the earlier horse cases here in the Okanagan, and now the last 2 years, the outbreak in the horses here in the east of the southern part of the province. And overlooking all the maps and overlooking all the data, it struck me that really we've been actually pretty lucky here with West Nile virus infection in British Columbia. We really haven't had comparatively that much of a problem with it, and it's mainly been in horses. So I was wondering, like, what could affect the low prevalence in British Columbia? So that tempted me to go and look at factors which affect West Nile virus disease transmission and expression. So of course we're going to be looking at amplification and transmission, which is dependent on interactions between the vectors, the host, and the virus. And we superimpose all of that on different ecosystems, different geographic areas. And of course here we live in a temperate region, so we have a seasonal activity, and the transmission must cycle again every spring. So there's a lot of factors that go into the expression of West Nile virus disease. So of course vectors and hosts are key to this. We've got to have a local concentration of the avian hosts and the vectors. They've got to be capable of sufficiently amplifying the virus to create the disease. We need winter survival of the virus, which can happen in our Culex species mosquitoes, which are the dominant vectors out here. And we also know that the virus can persist in the avian host for up to 8 months in some cases. So I wanted to look at 3 factors today. Temperature is the first one, of course. This affects mosquito development, the time that their development starts, the rapidity with which they appear in the spring. It'll affect their biting behavior. It affects the avian migration, avian activity, which all in total affects virus amplification. So in general, temperature will be directly correlated with increased virus amplification and transmission and expression of disease. Water, of course. Have to look at water when we're talking about mosquitoes. And local hydrological conditions are more important to expression of disease. It correlates more closely with what's going on the ground than actual precipitation. It has to do with precipitation and melt of snowpack in the spring. And there is a correlation between high rainfall, because it does increase standing water for mosquito development. However, heavy rainfall actually flushes mosquito vectors out of these water sources and can reduce the expression of West Nile virus infection. Paradoxically, low rainfall has been associated with increased West Nile virus infection, especially in the prairies. They believe it's because it reduces the standing water available, so it concentrates the mosquitoes and the birds at those sources of water and increases the chances for contact and virus transmission. Now, the third one I want to look at was one that interested me the most, and I hope you'll find it interesting too if you don't already know about it, and that's vector feeding patterns. So the composition of avian host communities and the feeding patterns of the vectors within that community will determine the success degree and length of West Nile virus transmission. Amplification hosts transmit pathogens to vectors, whereas the dilution hosts, these are birds that are bitten by mosquitoes, but they don't become infected and they don't amplify the virus. So an infected mosquito who wants to transmit West Nile virus is wasting his time biting these dilution hosts. He needs to bite an amplification host who's going to ramp up multiplication of the virus. So here in the West, we have two mosquito species, Culex pipiens and tarsalis, who are very good at transmitting West Nile virus, and they are the dominant vectors of the virus here in the West. So I wanted to look at 3 avian hosts today and compare them. First of all, crows. We know they're highly susceptible to West Nile virus infection because so many of them die when they contract the infection. As far as an avian host, they're not as plentiful as songbirds, and they have a high mortality rate when infected. So they essentially act as a dilution host, even though they can become infected and multiply the virus. They generally die, so they don't live long enough, and there's not enough of them to really efficiently transmit the virus back to the mosquitoes. Sparrows, we know, are very plentiful, and studies have shown that mosquitoes do feed on sparrows, and sparrows do become infected with West Nile virus and can act as amplification hosts. But mosquitoes, our Culex mosquitoes, don't particularly like feeding on sparrows. They prefer the American robin. This is reported to be the preferential feeding target for Culex mosquitoes, and it's reported that these birds, the robin, account for 60% of the West Nile virus infected mosquitoes. Therefore, American robins have been denoted the super spreaders for West Nile virus. Mosquitoes feed on these robins from May to August, and sometime in August and September, the feeding patterns of these mosquitoes shifts away from birds, not just robins, but also sparrows and other birds, to non-avian mammals. From what I've read, nobody really understands why. Some people have suggested it has to do with late summer, early fall migration, has to do with birds leaving roosting areas. Anyway, they're not sure, but what they are sure about is the feeding shift does occur. They stop biting birds, they start biting humans and horses, and that's why you get the late summer outbreaks of West Nile virus infection in the mammalian hosts. So just to finish up, I wanted to look at one little study that I thought was really interesting that was done in western US, but I'm just going to concentrate on the results from Washington State. These researchers looked at the effect of ecosystems on West Nile virus expression, and they were basically looking at orchards, vegetable areas, and forage crops outside of urban areas, and correlating these areas with the prevalence of West Nile virus infection and the concentration of vector mosquitoes and avian hosts. And what they found was West Nile virus infection in horses was highly correlated with the acreage used for orchards in Washington State, but not humans. They also found that the vector mosquitoes increased in correlation with the size of the acreage covered in orchards in Washington State, and so did the robins and the house sparrows. So everything went up together. The vectors, the avian hosts, the dead end hosts, horses, not humans, concluded that orchards provide feeding and nesting sites which facilitate vector-host contact and pathogen transmission to nearby horses. So I thought that was an interesting little study. Anyway, I'm wrapping it up. West Nile virus has had a profound effect on North American horses since its introduction in 1999. BC has been relatively spared. We've only had 17 cases of in-province contracted West Nile virus infection since its introduction in 2009. In all of those equine cases, there was either no vaccination, inadequate vaccination, or nobody knew the vaccination history, which suggests maybe they hadn't been vaccinated. And we can conclude that West Nile virus affects unvaccinated or poorly vaccinated BC horses periodically in the southern part of the province, with little predictability as to where it might appear from year to year. And that's it. So take any questions. These are my references.
Thank you, Anne. Questions for Anne, and while you're thinking, a reminder for the people on the webinar, we're happy to have you participating, and if you have any questions, you can email them to Kirsten, and we will read them out. Any questions for Anne? Anything to say on the matter? Always, yes. Yeah.
Ryan's so slim. And just a quick question, do you have any idea how many horses are vaccinated, and do you think it's effective at protecting, especially the border horses?
I don't really have any data on how many horses are vaccinated, but I would, if anybody else in the audience has the answer, I would welcome their input. I would say, just from my decades of involvement in the equine community, that the vast majority of horses here in the Lower Mainland are vaccinated adequately. Yeah.
For practitioners to start
absolutely.
Vaccinating horses, so
Yeah.
I'm sure that's probably helped.
Yeah.
Your microphone doesn't work well.
When they first reported the detection in Whatcom County, the vaccine sold out. You could not get the vaccine. And then, as we didn't have cases, people kind of fell off vaccinating their horses. But yeah, most people do vaccinate, and the vaccine is effective. You will notice in all of these numbers, the horses that contract West Nile virus, and of course these are horses that are only contracting the neurological signs, because horses that have a bit of a malaise, or horses that don't contract or don't develop signs, are not going to be tested for West Nile virus. So these are only horses that have neurological signs. And virtually all of them were either not vaccinated or inadequately vaccinated.
Yeah, okay. Thanks very much. I'm trying to be quiet here. So we've been looking for West Nile virus, expecting it here for 15 years. Why don't we have it? And I don't expect you to have the answer, but I absolutely don't know. There's no logical reason that I can think of why it shouldn't be here. I can understand it not crossing the Rocky Mountains, but why has it not moved up from Washington?
Well, that's what fascinated me, as well as you, and that's why I just thought I'd go over some of the most important transmission factors. And I don't think anybody can answer your question. I mean, if we were that brilliant, the world would probably be a lot better place than it is if we could figure those sorts of things out. It's so hard to predict. It's a vector-borne disease with avian host, and it's very difficult. But I think we're lucky that we don't have as much as some other areas of North America or even Canada have. Well, some people feel stung by the election. I guess you could say that.
Thank you, Anne.